Hey everybody, it's Jane from Wright and NSW PEP. When I started NSW PEP Talks, we did some basics, and one of them was on thermal basics, and I said I'd come back and talk about the different components, so let's start that now. Today I want to talk about CRAC units, what they are, and how they differ from commercial HVAC units. So let's get started. CRAC stands for Computer Room Air Conditioning. There are several videos in our NSW HVAC Academy series that cover the basic components of the refrigeration cycle, but I'll do a quick refresher here. Let's pull in this drawing of the refrigeration cycle. So starting down here at the compressor compresses the refrigerant into a high temperature vapor. The refrigerant then goes to a condenser where a fan blows air over the heat exchanger or coil, and the heat is rejected to the outside. From here, the cooler liquid refrigerant goes to an expansion device where it becomes cold, lower pressure liquid, which is sent to the evaporator. Here, a fan blows air over a cold refrigerant liquid, which cools the air that is sent into the computer room to cool the equipment. This is essentially a CRAC unit. It works much like your HVAC system at home. But CRAC units look different than you'd see on your house or even commercial units. So let's move this over and look at one. So this is the Vertiv DS unit. You can see the blower here at the bottom of the unit. The cooling coil is right here in the middle, and over here is the compressor section. I can't really see at this angle, but the expansion valve would be around this area right here. So let's move this over again. So unlike regular air conditioners, CRAC units are designed to maintain very precise temperature and humidity levels to prevent equipment damage from overheating or condensation. CRAC units are designed specifically to cool electronic equipment. Electronics generate pure sensible heat, that's heat without humidity, and they require continuous cooling. Built-in HVAC systems are designed to keep people comfortable. Around 70% of the cooling load is considered sensible heat, and the remaining 30% is latent heat. By contrast, in a data center, the CRAC units handle 85% or higher sensible load. Let's slide this over one more time. Servers and other IT equipment are designed to operate within a certain temperature and humidity range that must be maintained. Conditions outside these ranges can cause degradation of performance and shorten the lifespan of the equipment. CRAC units also have much tighter control than commercial HVAC systems, especially humidity control. When humidity is too high, moisture can condense on electric components, causing short circuits and corrosion. But too low humidity increases the risk of static electricity buildup, which can damage sensitive electronic components when discharged. Let me make a little more room. CRAC units are also engineered to operate continuously. The service requirements are much more stringent than with comfort cooling, and it calls for servicing at greater intervals. And because they're serving IT equipment instead of people, the units can have higher airflows and higher discharge velocities, as well as higher sound levels in the space. So let's pull all of this back on screen. So that's a quick overview on CRAC units and how they differ from commercial or residential HVAC systems. Don't forget to like and subscribe to our YouTube channel, and thanks for watching.